About a week ago, I made a video where I was creating a reversible air valve using 3D printing, and here it is. I did test it on the day that I made it using a compressor on a low pressure. But the whole project is meant to be done in a different way. I'm going to go through what my expectations are. For the last week, I've been thinking about this little valve here, and I'm a little bit concerned that I might have got a bit excited. I guess to begin with, I'll show you the actuator that I want to move up and down. And you can see quite clearly here, with a bit of compressed air, that's really easy to do. But I want this to move up and retract. And that was my purpose for building the valve that was reversible, so that I could have this extend and then retract just by turning this little knob here into one of those two positions. To do that, I need a source of vacuum pressure and air pressure. This is where I plan to get that source of air and vacuum. This is a little diaphragm type pump suitable for water and air. I'm hoping to use it to extend and retract this syringe. So I've got it hooked up here to a 6-volt power supply. What I'm going to do is plug in the syringe to the output and turn the power on. Okay, and you can see there that the little pump does a pretty good job of moving the piston up through the cylinder. Now I'm going to put it on the inlet side of the pump and turn it on again. And you can see there that the actuator retracts. I'm hoping to experiment with this sort of thing in my classroom with a group of students. The question is, can I hook up this valve and have my system run forward and reverse just by turning this knob? That's the mission. Am I going to succeed? So for this to work, I'll need to plug the inlet to one side and the output to the other side. And then I need another piece of hose My theory is I should be able to turn this on and move the piston up and down. Okay. Unfortunately, nothing's happening. There's a little bit of pressure. But it's just not enough to overcome the friction of the rubber seal in the syringe. When I made this, I knew that there would be leaks in the system. I guess I was just hoping that the leaks would be overcome by the pump, but this is a pretty small pump. What I could do is test it with the compressed air as the input. I'm going to give that a try. With enough volume and pressure, I can actually drive that piston out. Unfortunately, using it like this is not going to provide me with any vacuum pressure, which is what's needed in here to retract the actuator. Also, I can feel air pressure coming out through everywhere in here, through the seal, between the body and the cap, through the join around the 3D printed thing there, the little ridges and lines in that are leaking, even around the point where the spigot comes through the cap is bubbling away. I can test this in both positions and I can prove theoretically that the valve does work, but you can hear all of the air escaping. This is my disappointed face. To be fair though, I should have known better. I've worked with hydraulic systems enough times in my life to understand that fluid will escape through any path that is not 100% sealed. 3D printing with an FDM printer, I had to make my tolerances huge to just get that little rotating valve core into that body to freely turn. Up until this point, I'm going to call this a fail. I think I might be up against a brick wall of problems here. I think to make this valve properly, I would have to get my tolerances extremely tight, machine this with an accurate machine and probably out of aluminium or something like that.